Hello guys, this is a new Leetcode question called Sort the People. Okay, so here we are given a array of strings, names, and array of heights that consist of distinct positive integers, and both arrays are of length n. Okay, so for each index I, names I and heights I denote the name and height of ith person. Return the names sorted in descending order by the people's height. Okay, so we have given array names, okay, and heights. So we have to sort it in descending order for names. Okay, so as we can see here, uh, like Mary has the max height, okay, 180. Wait a minute. Yeah, Mary has the max height 180. John has height 165, and Emma has height 170. Okay, so we need to sort it in descending order. Okay, so first will come Mary. Okay, then will first will come Mary, then will come John, and then will come sorry, my bad. Then will come Emma, then will come John. Okay, I am writing the first letters just to simplify it. Okay. Second is okay. So let's see the approach first. Okay. So uh, like we just need to sort it, okay, in descending order. So we can just use quick sort or merge sort to do that, because quick sort has the lowest time complexity, and for the worst case merge sort has the lowest complexity. Okay, so we can just like if you use merge sort. Okay, so we will first take the array. Let's take the array height. Okay, so we will just map it. Okay, we will first map the height and okay, we first map the height and their names. Okay, in a map. Okay, so then we will take the heights array. Okay, and then we sort it. Okay, so let's take this array. Okay, 180, 165, 170. Okay, so first let's do merge sort. Okay, in merge sort we will just we will just divide and conquer method. Okay, just we will divide this and this. Okay, then we will sort it. Okay, so let's divide it. 180, 165, it's in one node, and 170 is in another node. Okay, so then we will compare. Now we will divide this two. Okay, so it will be like 180 in one node, 165 in one other node, and 170 in another node. Okay, so now we will compare these two first. Who is the smallest? 165 is the smallest. So we need to find a descending order. Okay, so we need to find the maximum here, because it's given in the question here. We need to find the maximum. Okay, it's given the question that we need to find the maximum. Okay, descending order. So we need to find the maximum height first. So in 180 and 165, who is big? 180 is big. So 180 will come first, and then 165 will come, and we will then backtrack to here, backtrack to 180. Okay, so then we'll compare it with 170. So 170 is less than 180. Okay, so 170. So 170 is less than 180 and greater than 165. Okay, so we will then again merge this two array, and we will write 180. Then second highest is 170. Then third highest is 165. Okay, so we will just return this like we will return the array like 180, 160, sorry, 175, 170, and 165. Okay, uh, yeah, this is the merge sort. Then we will just map all the numbers. Then we will map all the numbers and the names. Okay, like 180 will be Mary, 180 will be Mary, 170 will be Emma, and 160 will be one. 65 will be John. Okay. So you need to map it and then return the array. Okay. Then another method like this can be done for worst case. If we like want for average and best case, quicksort is the best. Okay. So what here we are doing is in quicksort, we will take the suppose 180, 165, and 170. Okay. So yeah, 170. Okay. So here in the quicksort, we will just take this as a pivot. Okay, we just fix it as a pivot, and we'll compare this pivot with this and this. Okay. So we will just compare the pivot is maximum than both the elements or no. Okay. We will just because start and end. We'll compare the start and end with the pivot. Okay, and then swap it if it's less than it. Okay. Oh, sorry, more than it for the here. Okay. So now 180 is greater than 165. Okay. 17. So we will just increase our S. Okay. And then 170 is then we'll check for end. Okay. End is less than 180. Okay. So it will be here only. Okay. So then we'll change the pivot to 165 then because it's the first element. We will just lock it. We'll just lock it. Okay. We'll just lock it. Just lock 180 and we will not change it now. So we have 165 and 170. This is similar to divide and conquer method. Okay. The only difference is like we are appending the same array, and in merge sort we are appending a different array. Okay? We have to make a different array for every time. Okay. So space complexity is optimized here. So 170. So then we will take this as a pivot, first element. Okay, and start will be here and end will be here. We'll compare 170, 165. The 165 is smaller, so we'll swap it. Okay, and 170 and 165 it will be like this, and then again merge with this 180. So it will be like 180, 170, 165. Yeah, and done. And then again we have to map this, and we'll get it. Array. So let's see the code for quicksort now. Okay, merge sort is similar to quicksort. So let's see the code for quicksort. Yeah. So this is the code. Uh, let me hide this. Okay. So this is the code. Almost it's of 35 lines. Okay. So let's write it again. Okay. Let's get a map, and then we will for I in uh, range. We will just map everything, heights and names. Range length of map. Okay. Sorry, length of names. Alright, so you can take anything because both are the same. Okay, and map of I. Okay, sorry, a map of name height of I is equal to names of I. Okay, then we will like now do the quicksort. Okay, so we will define a function called quicksort. Okay, and we will just pass the height array to it. Okay, then we will define a function called partition which will divide the array. Okay, this is the pointer for the array. Okay, divide and points to the pointer. So we'll pass the height to it. Okay, height, then the start point from where we should start, then the end point, and yeah, we just written this much. Okay, yeah, then we will check. So we will find a pivot first. Okay, so the pivot will be uh, our height of first element of the height. Okay, first element of the start that we are giving. That start will be the pivot because we are assuming the first element as the pivot. We can just take middle element or the last element as a pivot also. Okay, it's fine. It will the same. So then we will compare. We will compare while start. is less than sorry, okay, let's check. Okay, so we will take low, our first element as a start, plus 1, and our high will be our end. Okay, so from where to where we should compare it. Okay, so we'll check that. Then we will just compare while the start is less than equal to end. Okay, it's before the end. Okay, so we'll just compare it. Sorry, we can just take low is less than equal to high. Okay, and our start is let's look normal quicksort. Okay, so start is like greater than our okay, so our if height of start is greater than equal to our pivot. Okay, then we will just increment the start. Okay, sorry, let's take low here. We will just increment the low. Okay, and we will now compare for the last element. Okay, while low is less than equal to high, and height of low is less than equal to, sorry, the height of high is less than equal to our so it should be less than equal to our pivot. Okay, sorry, that's right, I wrote the wrong code. Okay, it will be less than, it will be greater than. Okay, then it will be uh I will just increment it. Okay, minus equal to 1. Then if our start is end, because start is less than equal to end, this means that we have struck any somewhere. Okay, so we are stuck somewhere, so we will just swap it. So it will be like, let's take this, it is here of star. Okay, we have taken low and high here, low and high, low comma high is equal to high comma low. Okay, we swap it, and okay, yeah, it's done. And we just after everything, we'll just swap the pivot and the start element and the end element. Okay, so it will be like uh, height of uh, okay, so we will swap here our start and our end. Okay, so our height, our higher top element. Okay, which we can this. Okay, so height is equal to high, we swap bring it and start. Okay, else we will, okay, yeah, we are done. Okay, and we will return our end. Okay, so now we will make a function called quick, which will pass the array, like the batches in the pass the array in batches. Okay, so it will be like height comma our uh, let's take low and high now. Okay, so like if our low is less than equal to high, let's take a variable like we want a partition. Okay, we want the index where we need to we need to divide it. Okay, uh, partition height, then our low, then our high. Yeah, we just need as much. Okay, then we will just do call this function recursively to divide it and sort it. Okay, so it will be like height low and high will be for, if for first will be x minus 1, so before that the pivot, and quick height x plus 1 after the element to the high. Okay, then we will just make low is equal to 0, like we have to starting point, and high will be length of height minus 1, and we'll call this function quick, which will initially start our quick sort. Okay, and our low and our high. Okay, and we will return height. Okay, sorry. So like this is the quick sort function. Okay, and we have mapped everything. Then we will sort the array now. Okay, so we will then map the array. Okay, so we will just uh, call the function. Okay, uh, quick sort, and pass it height. We just need heights. Okay, heights. Sorry, my bad. Heights. We need to pass the heights here. And then we will just return like, yeah, we'll just heights is equal to, yeah, we'll just return the our element now. For return the list for map of I for I in heights. Okay, so let's check it. Yeah, so where is the problem? Length of names. Okay, extra parenthesis. Uh, Map of heights. Okay, yeah, there's some spelling mistakes here. It's always a good thing to test it before submitting it. Okay, so what was the problem here? Okay, so let's see this. Yeah, so I resolved the error, and we were like looping in the wrong way, so it was getting giving us that error. Okay, so let's check it. Okay, now what's wrong? Mary John. Okay, yeah, we are sorted in the sorted way. Okay, so we have to reverse it. So it will be like minus one. Yeah, let's submit it. Yeah, yeah. Okay. Yeah, if you are using merge sort, it will just increase it. It will beat more people. Okay, it will be less time because it's less time complex for the worst case. For the worst case, quick sort gives n square, and the merge sort gives log n. So it's better to use merge sort. And uh, okay, let's reset it. We can, if you are using Python, okay, you can just return. Okay, we can just like if you want, we can just create a map in Python. Okay, it will work only in Python. Okay, for I in range length of uh, okay, length of names. Okay, we can just do like map of heights of I equal to uh, names of I. Okay, we can just now like heights equal to uh, okay, heights dot salt reverse equal to true. Okay, so it will just give it descending order, and then just return the same thing. Okay, we can just copy it from here. Okay, we can just return the same thing, and we will just remove this. So now it will work. Yeah, map of array. Okay, yeah, yeah. As you can see, it is giving us the thing. And listen, guys, this will only work in Python. Okay, and see, beats 99.65% people. It's like in fact of criticism, you can just use it if you want to just submit the code. If you want to understand this, you have to use this. Okay, you have to just quick sort or merge sort. Okay, it's better to use this. Okay, thank you. If you have a better solution, you can please comment down below.